Okay, question 16. The graph provided models Craig's trip to visit his friend in another state. In the course of his travels, he encountered both highway and city driving. So, question A. Based on the graph, during which interval did Craig most likely drive in the city? Explain your reasoning. So the first thing I want to do is, this is all about how to read a graph, not actually doing a graph. So, I mean, I can't graph this in my calculator. It's not going to help me at all. So I just want to look at each of these changes and saying what's happening from each letter. So the easiest one is from letter B to letter C. In this interval, nothing is changing. So the miles traveled stays exactly the same. So my slope M equals 0 because nothing changed in this interval. Now, when I look at this interval from 0 to 110 miles, so my change in y was 110. My change in x was 2. I'm reading the scale. There's 4 clicks, 4 grids, but they're counting by every other one. So they put a 1 here, they've got a 1 here. So this is actually 110 over 2. So at that point, he's driving 55 miles an hour. Now, as we move up, we go to the very top. It's from 200 to 230. So our change is 30 miles over the course of 2 hours. So that's 15 miles an hour at the very top. And finally, the span in the middle is from 110 to 200, but between 3.5 and 5 hours. So at that point, he's driving 60 miles an hour. So based on the graph, when did he drive in the city? So now I know we all see some people drive really fast in the city, but as a general rule, you're not going to consistently drive 55 or 60 miles an hour in the city without causing an accident or something, because you've got red lights, you've got pedestrians, there's way too much going on. So those two speeds of 60 and 55 don't make a lot of sense. So we have to assume that during interval D to E is Craig's city driving. So the answer to part A, during the interval from D to E, Craig was driving at a speed of 15 miles per hour in the city. So slower driving in the city, and we were explicit in stating why we think that. Now for B, it says explain what might have happened in the interval from B to C. So if we look at B to C, his distance did not change. So you can choose any reason that makes sense, but two things you should say is Craig stopped for a break, for lunch, he had a flat tire. There could have been any reason why he stopped, but if his distance traveled did not change, he definitely stopped. So for answer C, it says determine Craig's average speed to the nearest tenth of a mile per hour for his entire trip. Now, this looks hard because we've got all these different slopes here, but we don't care about all these different slopes. All we care about is that he traveled 230 miles and it took him 7 hours to do it. So our slope says 230 minus 0 because he started at the origin over 7 minus 0. So 230 over 7 calculates to 32.8 0.571. So the one thing that makes me absolutely insane when we grade Regents exams is rounding. Students seem to struggle with rounding. They're really good at it in middle school, but then somehow when they get to high school, they forget. So let me show you a trick for round. Menu, we're talking about a number, so choice 2. We're talking about number tools, and choice 1 is round. So we're going to take that number that we calculated, and if I want to round to the nearest tenth, that's one place past the decimal. If it was hundredths, that would be a 2. If it was thousandths, that would be a 3. So I just put in a 1, tell it to round, and it tells me that that 5 tells the 8 to go up to a 9. So 32.9 miles per hour. And this was a 4-point question, and that's how to get all 4 points for question number 16.